We will continue with our topic on coastal protection. This example of a tapering groin field, whereby the longest groins are used only in the intermediate sections of the groin field, whereas on the most updrift and the most downdrift direction, shorter groins are constructed in order to reduce downdrift erosion and to promote transport past the downdrift groin along the shore. One example of such a groin field is as shown here near Dungun. To design for a tapering groin field, length adjustment is carried out for the most updrift and the most downdrift section of the groin field. Here, let's consider a groin field whereby the groin length is Ln and the groin spacing is Sn. We assume that these two values has already been designed for, and they are being applied to all the intermediate groins so that they have the space to length ratio R equals to Sn over Ln. At the end of the groin field, we have this tapered section whereby the length of the groin is reduced from Ln to L1 to L2 to L3, and the spacing of the groin also is reduced to S1 to S2 to S3, while maintaining the same space to length ratio of R, which means that S1 over L1 is still equals to R, S2 over L2 is also still equals to R, etc. The tapering is done at an angle of 6 degrees. You notice that this allows the groin field not to terminate abruptly with a long groin, which may cause excessive erosion on the downdrift side, but taper off staggeredly so that there will be some degree of sediment downdrift to the end of the groin field, such that this section at the very end will not experience excessive erosion. Based on the geometry, the length of the tapered groin depends on the length of the previous groin minus the spacing times tangent 6 degrees. And whereas the spacing can be calculated as the average of the two groins multiplied by the space to length ratio. If we are able to calculate L1 and S1, then we can proceed to calculate L2 and S2, L3 and S3 as shown in the next slide. So this is the summary of how the progression of the calculation may look like. In general, for the tapered groin section, the groin length Lj can be calculated based on the previous groin length, and the groin spacing Sj also can be calculated based on the length of the previous groin. The example computation here is based on the shortening of the three groins shown in the figure that we have just discussed. We are going to assume that the normal spacing of the groin field is 152 meters and the normal groin length is 76 meters, so that the space to length ratio is equals to 2. By applying this equation, we are able to calculate L1 as 61.6 meters and subsequently L2 as 50 meters and L3 as 40.5 meters. And by using this equation, we are able to calculate S1 as 137.6 meters, S2 to be 111.5 meters, and S3 as 90.5 meters. We can validate the dimensions of L1, L2, L3 as well as S1, S2 and S3 as calculated here using the original trigonometry equations as shown on the previous slides.